Welcome you back in geological knowledge. So today we will discuss a very important topic that is related to the earthquake microzonation or earthquake zones of India. But before we discuss this topic, we must understand this map which has been released by government of India. Okay, the seismic zones there they have been uh, designated, and the earthquake hazard map that is showing the faults, major type of faults, thrust faults, and the earthquakes of magnitude greater than 5 on the Richter scale. So as you can see, there are three types of circles: the smaller circle, the medium circle, and the greater circle. So as you can see, the intensity on the Richter scale that has been shown, the smaller scale, the smaller circle that represents 5 to 6 Richter scale intensity, and the medium circle that represents 6.1 to 7, and the greater circle or the larger circle that represents 7.1 to 7.9, and the one which has been shown by the red color and crossed by the yellow color, so that represents the magnitude of the earthquake of magnitude greater than 8 on the Richter scale. Okay, and the index you can see the faults, the subsurface fault, the shear zones, the neotectonic fault, thrust fault, neotectonic thrust, trench axis, the suture zones, normal faults, as well as the strike slip fault. And the volcano, two important volcanoes in our country, that is the Narkundam volcano and the Barren Island volcano in the Andaman and Nicobar Islands. So these have been shown by the yellow color with a red dot, and the four zones they have been shown: zone 5, zone 4, zone 3, zone 2, and which have already also been designated by very high damage risk zone, the MSK scale, and MSK means the Medvedev, Sponheaur, and the Karnik scale, and in the short form or in the abbreviated form it's known as MSK scale. Zone 4, that is high damage risk zone. Zone 3rd is moderate damage risk zone, and zone 2nd is the low damage risk zone. Okay, and in the diagram, as you can see in the map, you can see the colors. So the faded colors, they show the low intensity, low risk zone like zone 3 and zone 2, and zone 4 and zone 5, which are shown by the bold red colors, they show the high risk damage zone. Okay, and I will provide the link of this PDF file in the description box, and from there you can download it from the Telegram channel. Okay, so now we come to the descriptive part. We will talk about the earthquake hazard zoning of India. As we know that in India, earthquake frequency occur along the foothill zone of Himalaya, because Himalaya is bounded by several fault zones, and they start from Kashmir in the west and Assam in the east, and there have several earthquakes which have occurred in Indian subcontinent, especially the Assam earthquake, the Bihar earthquake, the Kutch earthquake in the Bhuj area, and the Maharashtra Koyna earthquake in Maharashtra. So these are very devastating earthquakes which have occurred in the geological past or in Indian subcontinent. And this is the same map as we have discussed earlier. Because this map is not so clear, that's why I have discussed it differentially, in the different slide, and I will provide the link as I have said. So this is the earthquake hazard zoning map of India. Okay, and we all know that in Indian subcontinent has a history of devastating earthquakes, and the major reason for the high frequency and the intensity as well of the earthquakes, that is the Indian plate that is driving into the Asia at a rate of approximate 47 millimeter per year, or if we talk about in terms of centimeter, that is 5 centimeter per year. So that is a huge displacement in terms of the displacement, and The geographical statistics, if we talk about of India, so that show almost 54% of the land mass that is vulnerable to the earthquakes. Okay, so the 54%, almost 54% of land mass that is vulnerable to the earthquakes. And the latest version of the seismic zoning map of India that given in the earthquake resistant design code of India, that is the Indian Standard 1893 Part 1, that assign 4 levels of seismicity for India in terms of the zone factors. So earlier there were 5 zones: zone 5, 4, 3, 2 and 1, but now in the new standard, so zone 1 has been merged with the zone 2. Okay, so there are only 4 zones: zone 5, zone 3, zone 2 and zone 1. Or in other words, we can say the earthquake zoning map of India divides India into 4 seismic zones: zone 4, zone 2, 3, 4 and 5, as we have already discussed, unlike its previous version which considered of 5 or 6 zones for the country. Okay, so now there are only 4 zones. So this question has been already asked in not only in the geology but also in the other competitive exams. And according to the present zoning map, zone 5 that accepts the highest level of seismicity, whereas zone 2 is associated with the lowest level of seismicity. So zone 5 that accepts the zone 5 expects the highest intensity zone of earthquakes or the seismicity, and the zone 2 that is of lowest level of seismicity. The latest seismic zoning map can be assessed from the IMD website, and I have provided the link also, you can download it from there. And the MSK scale intensity broadly associated with the various seismic zones is 4 or less, 2 and zone is 6 or less, 7, 8, 9 and above that for the zone 2, 3, 4 and 5 respectively. Okay, and corresponding to the maximum considered earthquakes. Okay, so the MSK intensity broadly that associated with the various seismic zones: zone 6 or less, or zone 7, zone 8 and zone 9. And the IAS code, or the Indian Standard Code, which follows a dual design philosophy. So the under low probability or extreme earthquakes events, or the structural damage should not result in total collapse. Okay, and the under more frequently occurring earthquakes events, the structure should suffer only minor or the moderate structural damage. So there are two IS Indian Standard Code, that one refers to the structural damage that should not be result in the total collapse, and another one that deals with the structure should suffer only minor or the moderate structural damage. The specification given in the design code of Indian Standard 1893 are not based on the detailed assessment of maximum ground acceleration in the earth zone on each zone using a deterministic or the probabilistic approach. Okay, instead the each zone factor represents the effective period peak ground acceleration that may be generated during the maximum consideration maximum considered earthquake ground motion in that zone. Okay, so the base has also been cleared. So the specification in the Indian Standard Code 1893, that is not based on the detailed assessment of the maximum ground acceleration in each and every zone. Okay, but that is based on each zone factor that represents the effective period of peak ground acceleration, means the peak ground acceleration at that time which has taken place. okay, and that can be generated during the maximum considered earthquake ground motion in that particular zone we are talking about. And if each zone that indicates the effects of an earthquake at a particular place, which is based on the observation of the affected areas, means how these zones have been demarcated and how they have been demarcated, so that each and every zone that indicates the effects of an earthquake at a particular place based on the observation of the affected areas, means the areas on which the earthquakes have taken place in the past, so on that basis, means on the basis of their damage as well as the intensity as well as the destruction, the zoning has been done, okay, and can also be described using a descriptive scale like modified Mercalli intensity scale, or the Medvedev, Sponheaur and Karnik scale, okay. So now we talk about zones. So zone 5 that covers the areas with the highest risk zone, as we have already talked about, that zone 5 that is the zone of highest risk zone that suffers earthquakes of intensity MSK 9 or greater than that. And the Indian Standard Code assigns zone factor of 0.36 for the zone 5. So zone factors, as we have discussed, which have been assigned, which have been given by the Indian Standard Code. So zone factor of 0.36 for the zone 5 has been assigned, and the structural designers use this factor for the earthquake resistant design of structures in the zone 5, okay. So this zone factor that is very important as well as significant when the structural or the architects they design the uh, any engineering construction material or any building or earthquake resistant design of the structure in the zone 5. And the zone factor of 0.36 that is indicative of effective, that is a zero period peak horizontal ground acceleration of 0.36 gram, or in terms of percentage we can say 36% of gravity that may be generated during the earthquake in that zone, okay. And it's referred to as the very high damage risk zone, as we have already talked about, that is zone 5 is the very high damage risk zone. And which areas or which states they cover the zone 5? So the state of Kashmir, the western and the central Himalaya, northeast part of India, and the run of Kutch. So these three parts, Kashmir Valley, the western and the central part of Himalaya, the northeast Himalaya or the northeast Indian states, and the Kutch region, the run of Kutch especially. So that includes zone 5. And generally the area having trap or the basaltic rocks, they are prone to earthquakes, so especially the Deccan trap part, okay, because that is the trap or the basaltic rocks are there, so that's why that area is prone to damaging earthquakes. And if we talk about the zone 4, so this is known as zone 4 is also known as high damage risk zone and covers areas liable to MSK 8, and the Indian Standard Code that has assigned, so that is factor of 0.24. Factor of 0.36 was for the zone 5, and factor of 0.24 that is for the zone 4. And the Indo-Gangetic basin or Indo-Gangetic plain, the capital of the country means Delhi, the Jammu and Kashmir fall in the zone 4, okay. And in Maharashtra, the Patan area, that is the Koyna Nagar, that is also included in the zone 4, okay. So some part of Indo-Gangetic plain and the capital of the country, that is the Delhi, the Jammu and Kashmir region, as well as the Maharashtra state, and especially specifically the Patan area, that is the Koyna earthquake, as we have already talked about, that is the major earthquake which have taken place in the past, so that has also been included in zone 4. And if we talk about the zone 3, so the Andaman and the Nicobar Islands and some part of Kashmir, western Himalaya, that falls under the zone 3. and this zone is classified as moderate damage risk zone, which is liable to MSK 7 and also 7.8. Okay, and the Indian standard code that has been assigned for this zone, so the zone factor of 0.16 for the zone 3. And if we talk about the zone 2, so this region is liable to MSK 6 or less than that, and it has been classified as low damage risk zone, and the Indian standard code assigns zone factor of 0.10 and maximum horizontal acceleration that can be experienced by a structure in this zone is 10% of gravitational acceleration. Okay, so 0.10 means the maximum horizontal acceleration that can be experienced by a structure in this zone, that is 10% of gravitational acceleration for the zone 2. So this was our discussion about the seismic microzonation of the India or the earthquake zones in India, and this is quite important for the combined geoscientist main point of view, because this is the part of your syllabus and the questions can readily be asked. Okay, thank you.